Hi guys, Mr. A here again for maths, and today we are going to do the next step on from our last maths lesson where we were multiplying a proper fraction by a whole number. So today we're going to multiply a proper fraction by a proper fraction. I wish this little guy would keep still. Oh. Okay, so the success criteria for this lesson, we are aiming to be able to multiply numerators together and multiply denominators together second. So bear with me on that one because you're going to need to know that information. And we're going to be able to reduce a fraction to its simplest form by dividing the numerator and the denominator by the greatest common factor. Now that one we're okay, and we've done that before. So let's look at today's target. I can multiply proper fractions together, writing the answer in its simplest form. Brilliant. Okay guys, as you know, I don't like to let you get away without doing a bit of a starter. So I've got two questions here for you that's recapping on something that we did a few days ago. There's an addition and also a subtraction. So think carefully, get those brains into gear, pause the video now and have a go. Okay, let's see what we can remember. So with these, the first thing that I want to do, I've got 1 2/3 plus 3 1/4. The first thing I want to do is turn them into improper fractions. So 1/3 is 3 plus 2 more is going to be 5/3. This time we're dealing with quarters, but how many? 3 4s are 12 plus 1 more is 13. Okay, so we've got 5/3 plus 13 quarters. Now the only thing is the denominators are different and we need to try and make them the same. So what's a common multiple of both 3 and 4? What's the first one you come to? It's going to be 12. So our common denominator is going to be 12. Different colour. Now what do we do to this 3 to make 12? We'll multiply it by 4, didn't we? So we've got to do the same to the top as well. So 5 4s are 20. And what did we do to the 4 to make 12? We've multiplied that by 3, so we do that the same there. Now look kids, if you don't know, if you can't do it, let's just do a quick jotting. 3 3 is 9, 1 3 is 3. Or we could have just done 13 and 13 and 13. So we can put in there now a 39 twelfths. Now we can add those two up. 20 plus 39, well 20 plus 30 is 50. Add our 9 on and we've got 59 twelfths. Now because we've got an improper fraction still, we need to bring that to a mixed number. Now if you know your times tables, fantastic, that's great. If you don't and you need to do a fact box, get one done. 12, 24, 36, 48, 60. Right, we've gone too far now, so we want 59. The closest to that is going to be 48, so it's going to be 4 lots of 12 twelfths, right, 4 whole ones. We're dealing with 12 still, so we need to find out the difference between 59 and 48. Do another jotting if you need to. Well, 2 more on makes 50. From 50 up to 59 is 9. 2 and 9 is 11. Oops, wrong colour. There we go. 4 and 11 twelfths. Now, I'm always trying to look to see if I can simplify. Can I simplify 11 twelfths? No, there's not a common factor of both 11 and 12. So that's where we stop. 4 and 11 twelfths. Hopefully we got that, or even if you got part way, even if you got how to change the denominators to be the same, great, it's a step in the right direction. Now the next one is subtraction, and we still use the same principle. We're going to turn it into an improper fraction first. Okay, so here we go. We've got 2 sevenths here and we've got halves here. 2 7s are 14 plus 3 more is 17. 1 2 is 2 plus 1 more is 3 halves. Oops. Right, we've got to turn it into common denominators again. So if I was doing my 7 and my 2 times table, what would be a common multiple of both of those numbers? Well, it's 14, isn't it? Remember that top tip I told you? Multiply the one by the other, one denominator by the other. Yeah, it just so happens sometimes it works out really well. This is one of those occasions. So what did we do to that 7 to get 14? We multiplied by 2. And what did we do to that 2? We multiplied it by 7. So we must multiply the top by 7 as well. Okay, so double 17 is 34. See, jottings all the way. So we've got 34 there, and then 7s, 3 7s. We know our times table 21. Let's just move that away so we don't. Right then, 34. Take away 21 is 13. And we're on 13 14ths. Yeah. So 13 14ths, is there a common factor of 13 and 14? There isn't, so our answer must be 13 14ths. Hopefully you got that one right as well. So multiplying proper fractions. Right, let's take it a step at a time. Okay, keep it nice and easy, and hopefully build up to being able to have a method that we can use. Okay, as I say, I want to take it a step at a time. And first of all, I want you to be able to visualize what the fractions look like when you see the calculation. So at the bottom there, we've got 3 different calculations, and I want you to be able to relate one of those to the drawings of the fractions that I've got there. So in a minute, I want you to pause the video and decide which of those fractions matches up with the coloured parts of the fraction model that we've got there. Okay, pause the video. Okay, which one did you choose? That's right, it's 5 lots of 2/3. Each of these fractions has got 2/3 shaded. There we go, 2/3 shaded, and we've got 1, 2, 3, 4, 5 of them, 5 lots of. Okay, well done. Okay, another one for you. Okay, we've got the fraction model shaded, and I want you to match it up, the fractions up to the calculation across the bottom. Which one are you going to go for? Okay, pause the video. Alright then, let's have a look. So the first thing I would do to start off with is I would work out how many each shape is partitioned off into. Okay, so in this case we're looking at 6. Okay, now each one of these shapes is a 6, so there's 2 shaded in each one. Okay, how many have we got all together? So there's 1, 2, 3, 4. So we've got 4 lots of. So it's either going to be this one or this one. Oh, the dodgy looking question marks there. So we've got 4 lots of. So many 6ths. Well, the clue is there straight away, isn't it? 6ths. Let's just double check. Let's not automatically go for it, because we look at how many shaded on each of those. Yeah, there's 1, 2. So there's 4 lots of 2 6 shaded. So we don't need these question marks anymore, because you should be clicking that one. Okay, hopefully you're getting the idea of this now, being able to match them up. Well done. Okay, you get the idea now, guys. So I want you to match up the fraction model diagram to one of the calculations across the bottom there. So press pause on the video now and have a think. Right then, I don't know about you, whenever I see a triangle, the first number that comes into my head is 3. 3 sides, 3 angles, and then you've even got 3 shaded parts on each of those triangles. So that straight away comes into my mind. Now the thing is, you've got to be careful, bit of a trick question, because if you look at each one of these triangles, How many parts is it divided into? Well, look, we've got 1, 2, 3, 4. So it's actually the triangle, which we associate with 3, is divided into quarters. Now that gives us this possibility and this possibility, because they're the only ones where quarters have been involved. Right, so now how many triangles have we got? We've got 1, 2. So out of the 2 that we've singled out so far, this one's got 2, but this one's got 4. Right, so this one is a big no-no. Right, so it must be this one. So let's have a look. Yes, get in there. Well done, everyone. Okay, let's get some facts around us this time. Right, there seems to be more fractions, there seems to be more parts shaded, so let's go with the facts that we've got. Think about it really carefully. Count how many shaded parts, count how many whole parts that we've got fractions of, and compare them to the calculations at the bottom. We'll have a look at the answer in a moment. So press pause now for me. Okay then, right, what have we got? Let's get some facts together. As I say, we've got 3, 1, 2, 3 whole parts. Okay, so that gives us that one and that one. Right, definitely not that one. And for each one, what's it broken up into? 1, 2, 3, 4, 5, 6. Same again on the bottom row. 7, 8, 9, 10, 11, 12. So we're dealing with 12ths. Yeah. So we've already decided it's not that one. So could it be this one? How many shaded in each one? 1, 2, 3, 4, 5. So 5 12ths. So we've got 3 whole ones and 5 12ths. So we've got 3 lots of 5 12ths. Hopefully you've chosen that one. Brilliant. Well done. Okay guys, last one of these matchups, because I really think you're getting the hang of the idea now. Get some facts together and then compare them to the calculations that we've got across the bottom there. Okay, pause the video for me. Alright, let's have a look then. So what have we got? Let's get some facts. We've got 1, 2, 3, 4, 5, 6. Yeah, so it's either going to be that one or that one. What's each one divided into? 1, 2, 3, 4, 5. So we're looking at fifths. Okay, ooh, this is looking promising. That one was fifths as well on the end there, but we've got more than 3, so that's count that one out. So let's have a look. How many are shaded in each one? Well, we've got 1, 2, 3. So we've got 6 lots of 3/5. So hopefully you've chosen the middle one. If you have, well done. Okay, so the next step for us is looking at how to multiply proper fractions together. So I want you to pause for a moment and have a think about how we might solve this problem. Now, it's different to how we did addition and subtraction, where we tried to make the denominators the same. That's all I'm going to say for now. So come up with an idea and let's go with it, and we'll see whether you're right or wrong with your theory. We're going to come back to that question in a moment after I've showed you my method for multiplying proper fractions. Okay kids, dead simple, right? First we multiply the numerators together, 4 3s are 12. Then we multiply the denominators together, giving us 48, 6 8s are 48. We end up with 12 48s. If necessary, we need to simplify the fraction by dividing by the greatest common factor. here the greatest factor is 12. So what have we got? Let's just get my pen. We've got, if the greatest common factor is 12, 12 goes into itself once, and then 48, 12 into 48 go 4 times. So that gives us 1/4 as an answer. Told you it'd be easy. But can you see how important it is? I'm going to say it again, and I know you're going to get fed up of me saying it, but you need to know your times table. So important in maths. Okay, let's go back to that question I asked you to think about a couple of slides ago. 5/7 by 3/5. Did you come up with the method that I'd come up with? Let's see. So 5/3. So remember the last slide told us to multiply the numerator first. So 5 3s are 15. And then it told us to multiply the denominator. So 7 5s are, that's right, 35. So what's a common factor of both 15 and 35? Hopefully you've chosen 5. So how many times does 5 goes into 15? That's right, 3. 3 5s are 15. How many times does 5 go into 35? That's 7, isn't it? So you should have an answer of 3/7. We can't simplify it any further. There's no common factor of 3 and 7. Well done if you worked that out. If you stumbled upon it, just a wild guess, hey, well done. Okay, it was worth a try, wasn't it? If you tried other methods, can you understand how this method works? Hopefully you will. Let's try a few practice questions, shall we? Okay guys, let's have a look at these together then. So we've got 5/8 by 3/4. So using the method that we've just learned, okay, let's get red. We multiply the numerator first. So 5 3s are 15, and then we multiply the denominator second. 8 4s are 32. Can we simplify that at all? Is there anything that will go into 15 as well as 32? There isn't, is there? No. Okay, and next one. So we multiply numerators first. 2 2s are 4, and then we multiply the denominators next, and we've got 7 3s, which is 21. Does anything go in 4 and 21? No, nothing to simplify there. And the bottom one there, 2 3s are 6, or 3 2s I should say, and then we multiply the denominator next. 8 5s are 40. Now it's interesting because we can simplify this, not just because we're looking at 2 even numbers, but because we are. What should we use as a common factor? Do you want to start with 2? Keep things simple. Okay, let's have a look. How many times does 2 go into 6? Well, it's 3 times, isn't it? And how many times does 2 go into 40? 20 times. Is there any possibility of simplifying that even further? No, because there's no common factor between 3 and 20. Can you see how quickly we went through those? We went through quickly because the method is really quite straightforward. The only thing that's going to slow you down doing them is your knowledge of your times tables. Alright? So if you're not sure with the times tables, you're just going to have to do fact boxes, guys. Okay? And there's no harm in doing that. It just means it's going to take you a bit longer. But at the end of the day, getting them right is what it's all about. And if that's what works for you, then that's fine. But top tip, learn those times tables, guys. Okay, now you know the method then, guys. I've got some questions here for you to have a go at. Don't forget, double check. You might need to simplify them. In fact, top tip, you are going to need to simplify them. So pause the video now and have a go at these for me. Okay, now Mr. A is going to try A, to fit everything in each box, and B, to go through the whole of this worksheet without having to stop and re-record himself again for making a mistake. Right, what have we got then? So let's get a pen on the go. Let's go blue. So first of all, we've got 4/6 multiplied by 2/4. It's relatively neat for Mr. A. Okay, numerators first. 4 2s are 8, 6 4s 24. Hopefully you've got that far so far. Now, what goes into both 8 and 24? Well, 8 actually goes into 24, doesn't it? So we can use that as the common factor. 8 into 8 goes once, and 8 into 24 goes 3 times. 3 8 is 24. So you should have an answer of 1/3. Right, let's look at number 2, where we've got 2/5 multiplied by 3/8. So I'm doing the numerators first. 2 3s are 6, and then 5 8s are 40. Okay, and so we've got 6 over 40, and so a common factor between those would be, if we had 6 and we had 40, let's go for 2. So how many times does 2 go into 6? It goes in 3 times. And how many times does 2 go into 40? 20 times. Lovely. Right, on to number 3. We have got 4/6 multiplied by 3/5. Now that is going to be 4 3s are 12 and 5 6s are 30. What's going to go into 12 and 30? Well, 12, you multiply 12, it does go into 30, which is handy. Sorry, 6, what am I talking about? 6 goes into 12 twice. It doesn't want me to write, and 6 goes into 30 5 times. So that gives us an answer of 2/5, which we can't simplify any further. Next up, we've got 1/4 by 4/9. 1/4 is 4. 4 9s are 36. So what goes into 4 and 36? Well, we've just done 4 9s are 36. So we know 4 goes in. 4 goes into 4 once, and 4 goes into 36 9 times. Can't simplify that. And 3/4 multiplied by 4/5. Well, 3 4s are 12 and 4 5s are 20. Right, what can we do with that? What goes into 12 and into 20? Let's go for 4. 4 goes into 12 3 times, and 4 goes into 20 5 times. 3/5. On to number 6. How are you doing so far? Hopefully you're doing okay. And 6 elements multiplied by 8/10. Right, 6 8s. We've got 48, haven't we? And 7/10 is 70. Ooh, right, okay. So now I'm thinking bigger numbers, but hey, they're both even. So let's try and get them down to a more manageable number first. Always do that with a 2. So 48 divided by 2 is 24. And what's half of 70? Well, that's 35. Right, 24 35ths. We can't actually simplify it any further than that, so that's great. We've got 4/5 multiplied by 6 8s. Hopefully you did 6 4s are 24, and then you did 5 8s are 40. What goes into both 24 and 40? Well, let's do what I wanted to do on the last one and use 2 and show you how we do 2 steps. So 2 goes into 24 12 times, and 2 goes into 40 20. See, now it's more manageable, isn't it? We can look, see what we can get into 12 and into 20. Let's go 2 again. 2 goes into 12 6 times, and 2 goes into 20 10 times. And we can go even further. This is what knowing your times table is all about. Look at all the extra work that I'm having to do to simplify this. Whereas, if we knew our times tables, we could go straight there, couldn't we? So we could have just used 8 straight off. Right, well, if we use 2 again, 2 goes into 6 3 times, and 2 goes into 10 5 times. Whereas, if I just change the colour of my pen, if I'd have done 24, 8 goes into 24 3 times, and 8 goes into 40 5 times. All right, you see how much quicker it was instead of doing all those different steps. All right, let's have a look at the last one then. 2 6 multiplied by 4/5. 2 4s are 8, and 5 6s are 30. What can we do there? Let's use 2. 2 goes into 8 4 times, and 2 goes into 30 15. So that's our answer there. How did you do with those Not that difficult if you know your times tables, are they? Yeah. So all you've got to remember with multiplying is that you multiply across on both of them. Well done, everyone. Now, because I know you lot are a brainy bunch and you're up for a challenge, I've got a few more questions for you, and some of the later ones are a bit harder just to get your brains working. So press pause and have a go. Okay, let's see how you did. So first up, we've got 4/5 multiplied by not 2 eighths, but 3 eighths. I can't even write. So 4 3s are 12, 5 eighths are 40. What are we going to do with that? What goes into 12 and into 40? Well, 4 does, doesn't it? That's really easy one to do. So how many times does 4 go into 12? 3 times, and 4 goes into 40, 10. Can we simplify that? We can't. Not too difficult there then. So 6 sevenths multiplied by 5 eighths. 5 sixes, 30, 7 eighths, always stumps people out. And there you go. Where's my 56 gone? There we go. All right then. What goes into 30 and 56? Well, we could do 2. So how many times does 2 go into 30? What's half of 30? 15. How many times does 2 go into 56? Well, what's half of 56? First of all, what's half of 50? 25. What's half of 6? 23. Okay, 20. 25 plus 3, I should say, so 28. There you go, tripping over my own teeth today. Next up, 4 sevenths multiplied by 3 6. Well, 4 3s are 12 and 7 6s are 42. What goes into both 12 and 42? Well, 6 does, doesn't it? We've just done 6 for 42, and we know that 6 goes into 12 twice, so we end up with 2 sevenths. Brilliant. Now, a bit more thought on this one. Okay, we've got 8 twelfths multiplied by 4 tenths. Now, 8 fours, 32, not a problem. 12 tenths, 120. Now, this is interesting, isn't it? What goes into both of these? Do jottings if you need to. So what we're going to do is we're going to try. Think about how many times does 32 come up in the times tables? Well, the most common one I'm going to go for is 8. Right now, I know 8 goes into 32, so I'm going to try 8 into 120. Is there any harm in doing a little jotting? There isn't, is there? Does 8 go into 1? No. Carry it over. 8 goes into 12 once. What's left over? 4. Carry it over. 8's into 40 5 times. That goes in equally, doesn't it? So let's put that in now. 8 goes into 120 15 times. 8 goes into 32 4 times. Can we simplify that? No. That's just using the knowledge that we've got, kids. That's not working out straight away. That is just using the knowledge that we've got to try and solve the problem. All right. What have we got next? 8 over 12 multiplied by 5 eighths. Well, 5 eighths are 40 and 12 eighths are 96. And what goes into both of those? Well, 8 does, doesn't it? 8 goes into 45 times and 8 goes into 96 12 times. Can we simplify that? No, we can't. So although we were dealing with slightly big numbers with 12ths, it's not a difficult question. Now straight away I'm looking here and I'm thinking, well, that denominator is going to be big. So let's go for 426 multiplied by 3 tenths. So 4 3s are 12, and then 25 times 10 is 250. Right, what are we going to go for? Should we use 2 first to get the numbers down? Because 12's not that big, it's the 250. So let's do 2 as a common factor. 2 goes into 12 6 times. 2 goes into 250. Well, if you're finding out how many times 2 goes in, you're dividing it by 2. So what's half of 250? It's 125. So that's that simplified for us. All right, brilliant. Not that difficult, is it really? So let's look at our next one. 12 fifteenths multiplied by 4, 6. Well, 12 fours are 48. And then 15 times 6. Well, guys, if you need to, do a jotting. 15 times 6, it's going to be 90. Alright, so let's get our 90 in there. See, even Mr. has to do jottings. And I'm only slightly better at maths than you lot. Okay, what goes into 48 and into 90? Well, we've got 6 there to make 90. We've used 6, so let's go for 6, because I know 6 is a factor of 48, isn't it? So 8 6s are 48. 6 goes into 90 15 times, because I've just worked that out. 8 fifteenths. Not that hard. Alright. And our last one, 12 eighteenths multiplied by 5 tenths. 12 fives is 60. And we know that 18 times by 10 is 180. So yeah, it's big-ish, but look, see that 6 and the 18, there's a relationship there, isn't there? They're related to each other. How many times does 6 go into 18? 3 times. So 6 goes into 60. 60 goes into 60 once, and then the 60 would go into 80 3 times. So it would be 1/3. Or you could look at it. We could use 10. So if 10 was the factor, we'd end up with 6 and 18, and then we would end up with 6 going to 6 once and 6 going to 18 3 times. All right. So look, doesn't harm to do any jottings. If you got those right, slightly more challenging, well done. Well, brilliant, guys. You've attacked that success criteria really well today on the target. You've multiplied numerators first and then multiplied the denominators, and then you've managed to reduce a fraction down to its simplest form, and I made sure that nearly all of the questions that we've done today needed simplifying. Practice makes perfect, as I always say to you. So today's target, I can multiply proper fractions together, writing the answer in its simplest form. You've just got to remember the difference of multiplying compared to when we add and subtract. That's all you've got to do. All right. Have a look at the self-assessment. Where would you grade yourself there? Big smiley face. Somewhere in between. In fact, you look, that middle one looks asleep. Or a bit of a scratching chin. Still need to think about it. Remember what I always say. Go back through the video. Go over the examples once again and the explanations, and see if it sticks in your memory a second time. There's no harm, even a third. Right, you're proud of your work, you've presented it all nice and neat, and you think I'm going to be able to read it from the way you've set it out. Please make sure that you put your name on your work, take a photo and WhatsApp it in, send it to Year 6 email address, it's there on the screen, or, like I say, make sure the name's on, pop it into our new post box, and I'll have a look and get you some feedback. Well done, and see you next lesson, guys.